Welcome back to Environmental Science Theater. I don't know, right out of things to say. Chapter 11, Part 2. So, land degradation. With land degradation, hold on one second here and get myself ready so I can tell you right here. Different things affect it, right? And so, right we're here showing with land degradation, and in large parts, again, I'm talking about desertification. One of the biggest issues is drought, the lack of water. Now, drought can come in three different ways. Meteorological drought, which is just the weather has changed. So there's precipitation deficiency, which is a fancy word for saying that there's less rain, or it's not as intense, or it comes at different times of the year, right? And what happens with that? There's less infiltration for groundwater, there's less groundwater recharged, maybe the wind patterns change, there's less humidity, more cloud cover, which could increase evaporation so that groundwater or lakes and rivers dry up faster. So that's the first aspect. Second one is agricultural drought. And this is kind of like what we talked about with the Great Plains, right? The agriculture in the Great Plains is mainly supplied by groundwater, well water. And the more they use, the deeper the water is, the harder it gets. So even though the rainfall amount really hasn't changed in Kansas, it's getting harder to get well water. So soil water deficiency. And things that affect that, different plants need different amounts of water. In fact, the plants they grow in Kansas need more water than naturally is there. So that's plant water stress. And then the last one underneath me here is hard to see is hydrological drought. And maybe something happens to change the flow of water. So if you are in a swamp and they build a reservoir or the dam, or they change the river flow, they change the amount of water in the swamp. That would definitely be a drought. Um, Most of Chicago used to be swampy and marshy, and one of the things that we did, because no one likes to live in a swamp, unless you're maybe an alligator or anyone else, is we drained large areas of Chicago by making the river flow backwards, and we talked about that before. So, we filled it in with dirt, and that changed it. So, in some ways, you could say that Chicago is experiencing a severe hydrological drought since about the 1820s. But desertification, right? Taking what was once a prime land of some sort and making it the desert. Sometimes it's the desert's expanding, and sometimes it's just human action. And this map shows you here the areas that are primarily dry ecosystems. So here's the Sahara Desert right here. Very, very dry. They call that hyper arid. There are some areas here that basically never get any rain, right? But as you go towards the edges, it goes from dry to semi to humid. So like right here, it's not the Sahara Desert, but it is a dry environment, right? These areas are drier. And what that means is it's desert-like. Now the issue with this is these areas are very susceptible to human actions. Because here there's no rain, it doesn't matter. Here there's a little bit amount of rain. But because of the way you use the land here, that might make it more susceptible. So think about the US. There's only really a true desert right here, maybe in Nevada, Arizona. But large areas are semi-arid. Grasslands, Kansas, Nebraska, Oklahoma. And we've talked about this. It's the human method of farming that is basically creating an artificial drought. And so these areas here, if they're under pressures like poverty, population increase, or war, can have desertification increase. And in fact, large areas here are just under that, increasing population, poverty, and war. Now, in the desert, one of the most important things, the way that happens is the movement of dust. So, how does dust get around in a desert? There's no rivers, right? Dust storms, the wind. The fancy term for wind is aeolian. So if the wind is blowing the dust, that is aeolian transport. I just put this in because it reminded me like an old airline. Welcome to Aeolian Transports. But that's just a fancy word for dust transported by the wind, or a dust storm. And the wind moves up the dust, it blows it around. It can also increase desertification. One of the assignments you're going to watch this week is about the Dust Bowl, which is something that happened in the United States in the 1930s, where small areas that were desertified, the reaches of dust blown by this covered most of the western half of the U.S. But this is a major way that desertification happens. We can actually see it from space. This is dust blowing off the coast of Africa from the Sahara Desert. We can actually measure dust in the atmosphere in Florida that came all the way from Africa across the Atlantic Ocean. And this is what actually happens in the Dust Bowl. Wind blows all this dust and deposits it over fields. So if an area starts having less ground cover, and there's more dirt and sand that's exposed to the wind, and a big strong storm comes up, it can blow this hundreds of miles. It can even move bacteria. And I don't know why that would be important right now in this time and age to worry about bacterial movement. But if you can read between the lines of my sarcasm, it is. Diseases can actually be blown on the wind. You can see here we can actually trace the movement of dust and dirt here from Africa and Sudan all the way across to the Caribbean. So how does it happen? Aeolian movement. Well, here you have, imagine if you have, here's the floor of the desert. Here's the ground. You've got big pieces of sand and rock and little pieces of rock and really, really fine, almost like dust. If there's no wind, they're all going to sit here. But as the wind picks up, it starts to blow things. And the lightest things are moved first. So a light wind will make dust and smoke move. And if you've ever looked like a dust hanging in the air, that's actually tiny little pieces of dirt that are so small and so light they actually float. And so they're almost like they're being suspended, like smoke, right? Now, there are pieces that are bigger, and what happens is if they get blown across the surface and they kind of go up in the air a little bit and bounce, that's called saltation. So that's like the dust and dirt moving on the ground. If the piece of dirt or sand is so big that it can't get picked up, it just gets pushed and rolled, that's called creep. Now, how do you stop this? Because if that's something that causes desertification, maybe you want to stop the wind from blowing the sand. I don't know if you've ever seen these on the lakefront, these windbreak fences. You might see these in the summertime. Oftentimes they're used near highways in the winter to stop snow. The wind blows through these fences, but when it hits these wooden slats, it slows down a little bit. And why is that important? We'll go back to this. If the wind slows down, these things don't get moved as much. So you can see here the wind blows across the beach, hits this, it slows down and drops some sand right here. And now there's less sand in the air. So we can do this artificially. We can plant a row of trees or build structures or fences. Plants do it naturally. If you've ever been to the beach, there's no plants right here, but the further you get, you start seeing grasses and trees grow, and the roots actually anchor in the dust and dirt, and the leaves and stems act kind of like that fence to slow the wind down. So they slow the wind down, the sand falls in between it, gets trapped between the roots and stays there. Also the type of surface material. If we pave something over as a parking lot, well, there's no sand anymore. But if we maintain a surface that doesn't allow for dust and dirt, so you've got grass or trees. Here in the desert, we often get what's called a desert pavement. And this is just big, thick rocks. All the sand and dust has blown away and left us behind. But what happens if we have issues? What if the soil is not maintained well? What if we farm it and the crops die? Or we cut down all the trees? And then you have soil that's exposed to the air. And maybe we are managing the water poorly so it dries up. And now this is all dust and dirt. And if you've ever seen dust and dirt and you let it sit long enough, it becomes bone dry. All it takes is the wind to stir it up. So one of the things to stop desertification is to stop it from getting to this point. So we're going to look at this area of Africa called the Sahel as a study, kind of as an example of desertification in action. Now the Sahel, you can see right here, is kind of that semi-arid. It's not completely covered with trees or grass. There's still a lot of open dirt, but it's not completely desert. And the Sahel is the area between the Sahara Desert here in the north and the tropical rainforest of Central Africa. So we go from a very, very arid and dry climate to a wet one in this area. Okay, and the Sahel is constantly seeing these areas move as weather patterns and human actions change. The desert either moves south or north. But let's look at historical records. If we go back About 8,500 years ago, so before the very first civilizations, we had cities and villages but no writing. Here in Egypt, right here's the Nile River. This is just showing you rainfall. It was extremely dry. This was actually drier than it is today. The only water in this region was the Nile River. So people clustered in banks around here because that was the only source of water. But something happened about 8,000 to 7,000 years ago. Rainfall patterns changed. You can see the difference, much wetter. And as the desert became wetter, it allowed people to move out and farm. So we see a dispersed pattern. Excuse me. Following that trend, about 7,000 years ago, it's still pretty wet, but it begins to dry right about 3,500 years ago. The northern half of Egypt becomes very dry, and what happens is the people that were living here have to move and settle along the Nile. Now, why is that important? Well, the people that were living here were growing where they were raising cattle, and the people living here were farmers. But when the people who brought the cattle here met with the farmers, cattle raising became very important here, and it also became very profitable. At the same time, this clustering of people allowed one of the first urban civilizations to occur. This is ancient Egypt, the people that built the pyramids, because now there were more people living in cities, which gave them a lot more people to build things and make pyramids and develop writing. And so this action of forcing people to live back in cities may have very well led to the development of civilization. We can look at rainfall records over this is from the year 1900 to 2007. And what this is showing is just basically times that are above normal for precipitation or below normal. And you can see that from 1900 to about 1960, it was pretty much normal or above rainfall. But beginning in the 1970s through today, there were many years of below average rainfall. So again, in Sahel, this is just showing that the rainfall was changing. Let's look at another image of that. Why was it changing? We think that there's this. We have measured that there are little orbital changes. The orbit of our Earth around the sun wobbles a little bit, minutely, but it's just enough to change the amount of solar energy we have. If you change the amount of solar energy, the heating from the sun, just a little bit, it has huge, huge ripple effects. We've talked about these feedback loops. They're started by climate forcing. Climate forcing is something that affects the climate that is not climate related. The sun gets hotter or colder, and that has ripple effects. And so in Africa, it ends up shifting the monsoon patterns, the pattern of rain. It moves it north or south. If the monsoon moves north, the Sahara is wetter. If the monsoon moves south, the Sahara is drier. So that's a climate forcing issue. But it starts another thing we've talked about, right? And that are feedbacks. If you change the rainfall pattern, you start these feedbacks. So right here, reflected radiation albedo. You can't see it on my face, but if there's more rainfall, then there's more plant cover on the surface. There's more water, so there's more grass. Grass and trees don't reflect as much light back to the sun, so there's less albedo, which makes it cooler. If it's cooler, it allows for less evaporation, which means that the rain stays in the ground stays wetter, and allows more vegetation to grow, which reduces the albedo, which allows for even less evaporation. So you start this whole feedback we talked about. So the climate forcing starts the feedback. And so the Sahel got wetter. But now, let's go back to that. Let's go the other way, right? And now the Sahel is getting drier. And maybe we're actually seeing these things work backwards. So there's less rainfall on the surface, less vegetation cover, less plants, more sand, more rocks, which is more reflective. That reflects or absorbs more heat, which makes it hotter, which leads to more evaporation, which means less vegetation cover. And so if I go back 2 slides, right here, when there's more rainfall, that starts that feedback loop that makes it cooler and wetter. But the less rainfall there is, that's that feedback that just amplifies itself. Less rainfall means more open ground, which means hotter temperatures, which means less water in the ground, and it feeds itself. The other aspect, though, is the human interaction. So in the Sahel, I showed you this population growth chart before. This is actually for a population in Sudan. The population from 1998 to today has just dramatically risen. And so with population growth and the poverty that we see, right, we see that there's a lot more people farming land. Odds are if they're farming more land, the land that's available to farm isn't as good. If it was good land, it would have already been farmed. And so we see very marginal productions, overgrazing, getting as much as you can right here. Here we see cattle grazing, eating the grass to the ground, and what's left, bare dirt. So much so that in some parts of the Sahel, right here, we see as these cities increase, right, as they increase, we see greater areas of devegetation, open sand, because they're basically, cows are eating all the grass. And what happens is, over here, the desert's encroaching. It's getting hotter, and this area that used to be more grassland is being turned into desert. And unfortunately, this has been the result far too often, is turning the Sahel back into desert. All right, I'm going to pause right here. Time for me to go up and go get some dinner. Hopefully you'll do the same. And when we come back, we'll finish up with the last part of it, part 3.